Hello, welcome to the video. In this lesson, we're going to be looking at section 7.5, where we're going to be looking at properties of trapezoids and kites. So trapezoids and kites are a special type of quadrilateral because if you look at a trapezoid, a trapezoid is a quadrilateral that has only one set of parallel lines. And kites have two sets of congruent sides, but unlike like a rectangle or a parallelogram, their two congruent sides are consecutive sides. So it looks something kind of like this. So this side length would be the same as this side length, and this side length would be the same as this side length. So it'd be like consecutive side measurements are congruent, not opposite sides are congruent. So that's what makes a kite a kite. In this example, the first thing they want to know is this quadrilateral ORST a trapezoid? So in order to figure that out, the first thing you have to do is figure out what the slope is. So like between R and S, I'm going to find the slope. Here it goes up 1 to the right 2. So it's a slope of 1/2. Here I'm looking at OT, looking at the slope of this one. It looks like it goes up 1, 2, 1, 2, 3, 4. And so I have two. So I would say that RS is parallel to OT. Looking at the slope of RO, it's undefined. And ST, it looks like it's -1. So we do have one set of parallel lines. So I would say yes, this is in fact a trapezoid. The second question is they want to know if it is in fact an isosceles trapezoid. Isosceles trapezoids means that uh, RO in this case would be equal or congruent to ST. All right, so we got to see if that's true. So RO, I just count 1, 2, 3, so it's a value of 3. So what we need to figure out here is ST, a value of 3. So I just use the distance formula. So this is going to be what, 2 minus 4 squared plus 4 minus 2 squared. 2 minus 4 is -2. -2 squared is 4. 4 minus 2 is 2. 2, so that's plus 4. So this gives me the square root of 8. All right, square root of 8 is not 3. To answer their question, no, it is not isosceles. It is a trapezoid, just not an isosceles trapezoid. There are some theorems that that will help us discover if, in fact, a trapezoid is, in fact, isosceles. Here we have a base angles theorem. So if you know that um, that one set of parallel lines makes it a trapezoid, and you can say that the base angles are both congruent, you could say that the sides are going to be equal, which means it makes it isosceles. All right. Same thing here. If you have an just one set of congruent sides here, where they're the um, opposite sides here, and also you have a congruent, well, basically it says here, it says if angle A is congruent to angle D, or vice versa, you could say that it is. So you actually only need one of the angles in order to show that it's true. And then finally, if you're not given any angle measures, you're not getting any side measures, but they tell you that the diagonals are congruent. So if the diagonals are congruent, you can say it's an isosceles trapezoid. Here, it says the stone above the arc in the diagram is an isosceles trapezoid. So they say that KL is parallel to JM, and LM is congruent to JK. With that, we can use that information to help us find the measurements of K, M, and J, the angle measurements. So K is actually going to be the same as L, so K is 85 degrees. All right. Now, M and J are going to be the same. We just don't know what it is yet, but we also know that the sum of all four of these angles is going to be 360 degrees. So we could simply take 360, subtract it by 85, subtract it by 85, which gets us 190. We divide 190 by 2 because we have two more angles, which gets us 95 degrees for both angles M and angles J. In this example, it says use exercises 2 and 3. It says use trapezoid EFGH. So it says if EG is equal to FH, is the trapezoid isosceles? They're asking you to explain. The answer is yes. The answer is yes because we can use the isosceles trapezoids diagonals theorem. Because they said that if the two diagonals are congruent, which they are, EG is a diagonal and FH is a diagonal, I can say yes. In number 3, it says if the measurement of HEF, so this value right here, they're saying is 70 degrees, and they're saying that FGH is 110, is trapezoid EFGH isosceles? They're asking us to explain. Well, my conclusion would be is since EF and HG are parallel, so it makes it a trapezoid, and 70 degrees plus 110 degrees makes it 180, so I'm left with 180 degrees to disperse, so I could say that this is also 70 and this is also 110. So since these base angles are congruent, I could say yes, that it would also make it isosceles. Another theorem that we have for trapezoids, we have what's called a mid-segment theorem. Basically, you can find the distance of the midpoints of the two non-parallel, so the midpoints of the two non-parallel line segments. What you can do is the distance of the line segments, M and N, is going to be half of the sum of the two parallel line segments. So using an example, here it says that MN is a midsegment of trapezoid PQRS. They want you to find MN. So MN is basically going to be 1/2 times it by the sums of the two parallel lines, which is 12 plus 28. 12 plus 28 is 40. Times that by 1/2 is 20. So 20, and it was inches. So MN would be 20 inches using the midsegment theorem. Here they want you to find the midsegment of YZ. So the distance from here to here is the same as the distance from here to here. We need to find that. You could do one of two things. You could say, all right, so this value right here looks like it's at what, 4 comma 2, 4, 6, what, 8. And then this one here is at, so this is 2, so that's what, 12. That gets me 7. So this is going to be 7 comma 2. So now that I know what those two coordinates are, I can use the distance formula for that. So the distance of YZ is going to be equal to the square root of 4 minus 7 quantity squared plus 8 minus 2 quantity squared. So I get 4 minus 7, negative 3, square that, I get 9. So I get 9 plus 8 minus 2 is 6. 6 squared is 36. So 36 plus 9, I get 45. So I get the square root of 45. All right. That's, I would say, well, I guess we can simplify that. So because I could say that this is um, 9 times 5, which then would make it 3 times by the square root of 5. So that is my simplified one. If you're looking for to the nearest tenth, it would be about 6.7, we'll say. All right, kites. Kites have a couple of theorems. One, like I said, 2 consecutive congruent sides. Uh, one of the things that another characteristics of a kite is if you look at the diagonals, they intersect at a 90-degree angle. And also, opposite angle theorem states that the angle measures that share that are like the not congruent side. So like angle C is shared with BC and CD, they're not congruent, but AB and AD are also not congruent, but these two opposite angles are congruent. So that theorem states that. Here it says they're asking you to find the measurement of D. So I need to find this measurement, so it's like X. So essentially, because it's a kite, angle F is also going to be whatever the measurement of angle D is, so we'll call that X. So this is going to be like 2X plus 115 plus 73, and it's still a 4-sided figure, so it's going to be equal to 360 degrees. So 115 plus 73 is 188. So now I got 2X plus 188 is equal to 360. 360 minus 188 is 172. So 2x is equal to 172 divided by 2. X equals 86 degrees. So the measurement of angle D is 86 degrees. In this example, it says in a kite, the measures of angles 3x degrees, 75 degrees, 90 degrees, and 120 degrees. It says find the value of x. What are the measures of the angles that are congruent? So basically what you could do in this scenario is you are trying to find, so I got 3x plus 75 plus 90 plus 120. I do know that this is going to be a sum of 360 degrees. So I could take 75 plus 90 plus 120. I get 285 with those sums. So 3x plus 285 equals 360. So 360 minus 285, I get 75. So 3x is equal to 75 degrees. All right. This is already telling me that 75 is the angle that is congruent. But to find x, I just need to take 75 and divide it by 3, which is 25. So x is 25, and the congruent side measure is, I have two 75-degree angles for that kite. All right, so here it's asking you, it says, what is the most specific name for triangle ABC? All right, so all they give us is that whatever this diagonal, whatever this point is, I have congruent measurements from here to here, and I have congruent measurements from here to there. So going back into my theorems, if it is a rectangle, all of these would be the same. All right, so it's not a rectangle. So if it's not a rectangle, that means it's also not a square. If I have congruent side measures like that, that means right now there is what is called a parallelogram diagonals converse, which if you look in your notes from 7.3, it states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. They're not telling me that even though BC and AD and CD and AB may appear to be congruent, they don't tell us. So the most specific name of this quadrilateral is a parallelogram. All right, so again, these are assignments where it's like, hey, you just got to make sure that you only use what they give you. Don't use like what, kind of reasoning like, oh, it could equal each other, or it could be 90 degrees. Don't make those assumptions. You can only use what is given with us. It says quadrilateral DEFG has at least one pair of opposite sides that are congruent. What type of quadrilateral meets this condition? So it has at least one pair of opposite sides, not two. So that tells us that it's probably a trapezoid, and more specifically, an isosceles trapezoid. Or what types? So I guess so it has at least. So I guess then it could be parallelograms. It could be a rhombus. It could be a rectangle. And it could be a square. So it has the capabilities of, let's see here, an opposite. So it can't be a kite. In 8, 9, and 10, they're asking them to give the most specific name, and they ask us to explain our reasoning. So if we look at 8, all they give us is the measurements of the sides. Since we have consecutive congruent sides, this is a kite. Over here, all they give us is the diagonal measures, and all they tell us is they're not the same. And then they give us these two parallel line marks, and there's only one set of parallel lines, so this is a trapezoid. Over here, we got opposite sides are congruent, and the only thing they tell us is one set of diagonals bisect. And let me take a look here. So if I have, so they tell us that this is 9, which is, that doesn't tell us anything. Let's see. I would guess that since they don't tell us anything of value, like they tell us that they only have one set of, we only have one set of congruent sides. So that doesn't make it a trapezoid. So I'm going to say right now that this is all this is a quadrilateral. They don't give any other indication that it would be otherwise. And that is being able to look at properties of trapezoids and kites. I hope this helps. Till next time.